This is a demonstration of the OptimEyes Line Profile Tool. The Line Profile Tool is used to analyze the pixel brightnesses of the pixels along a line drawn on an image. Let's open an image and draw two line ROIs on it. The first will be a freehand line, and the second will be a straight line. We'll use the Line Profile tool to find the points where our ROIs cross the black bars. So let's open the Line Profile tool, and the first thing we'll do is add the profile of the straight line. The higher points on this line profile correspond to the light areas of the image, and the lower points correspond to the dark areas of the image. In order to find the edges, the Line Profile tool will calculate the second derivative of this profile curve. I won't go into the calculus of the second derivative calculation, but you'll see how it works in a moment. Before we calculate the second derivative, we want to apply a smoothing factor to help compensate for some of the random noise in the image. To do that, we'll open the Options dialog, and under Second Derivative, enter 1 into the Averaging field. This tells the tool to average each value in the curve with one of its neighbors on each side. We'll apply that setting and close the Options dialog. Now we'll calculate the second derivative and scale the graph to show it more clearly. Next, we're going to focus in on this portion of the graph, which corresponds to this area in the image. We do that by opening the Axis Min-Max Values dialog and setting the maximum x-coordinate to 150. To help explain what we're looking at here, I'm going to hold down the Control key on my keyboard and click the bottom and top points at the beginning of the curve. If you look at the image, you'll see that two lines have been placed corresponding to the points that I clicked. Let's zoom in and take a closer look at that. The first point that I clicked, the bottom point, corresponds to the place along that line ROI where the image begins to go from light to dark. The second point, the top point, corresponds to the place along the line ROI where the image finishes going from light to dark. Let's control-click on the next peak and valley. As you can see, now we have lines where the image begins to go back from dark to light and where it finishes going back to light. Next, we're going to have the Line Profile tool calculate the point between each of those pairs of lines where the edge of our dark bar is. Looking at the line profile graph, the edges are the places where our second derivative curve crosses the axis. But not every place where the curve crosses the axis is an edge in the image. Because of the noise in the image, there are lots of other places where the curve crosses the axis. We'll need to set thresholds to tell the tool what we consider to be noise and what we consider to be edges. The upper threshold will be in this range. Any peak below it does not correspond to an edge, and any peak above it does. Likewise, we'll have a lower threshold somewhere around here. To enter those thresholds and find the edges, we'll open the Show Edges box. The values that I've found are appropriate for our noise thresholds in this case are 6 and -6. The Find Edges dialog will find two edges at a time. The first is the up edge corresponding to the point where the second derivative curve crosses the axis going up, and the second is the down edge where the second derivative curve crosses the axis going down. Now if I click Find First, you'll see that the edges of the first black bar have been found and marked with purple and yellow lines, and corresponding purple and yellow lines appear on the line profile graph. To display the exact positions of and distance between those edges, we'll open the Distance box. The Distance box displays the x and y coordinates for both edges and the distance between them. Since we're measuring along a straight line, the line distance and straight distance are identical. Now let's find the edges of the next black bar. We'll click Find Next, and as you can see, the purple and yellow lines have moved to the second black bar in the image, and the corresponding purple and yellow lines on the line profile graph have moved too. Looking at the distance box, the positions of the edges and the distance between them have also been updated. Now let's find some edges along the freehand line ROI that we drew earlier. We'll zoom out. I'll right-click the freehand line ROI to activate it. Hit the Delete key to delete our old second derivative curve. Add the line profile for our freehand line ROI, and hit the Enter key to scale the graph so that we can see what it looks like. Then we'll take the second derivative and hit the Enter key again. And now, if I click Find First, you'll see that the edges of the first black bar along the freehand line ROI have been marked both on the image and on the line profile graph, and their positions and the distance between them are displayed in the distance box. Since the freehand line ROI is not straight, the line distance, or distance between the points along the line ROI, is now different from the straight distance. As we click Find Next, we can continue finding the edges of each of the black bars in the image.